Hello and welcome to Metrology in the Zone. I'm Bill Fetter from Hexagon Metrology, Inc., on site in the zone at HxGN Live. We're here at the beautiful MGM Grand Resort in Las Vegas with over 3,500 attendees from more than 70 countries. We're gathered for one purpose, to experience the great stories as told by Hexagon's global network of brands and our global network of users. I'm at the heart of the conference in the technology expo called The Zone. Over 4,500 square feet of technology and ingenuity from Hexagon's worldwide network of companies and partners. Today on HxGN Live TV, we're going to take you on a tour of the Metrology Zone and have a look at the latest and greatest technologies brought to you by Hexagon Metrology. We'll see what's new with vision technology, touch an entirely new PC-DMIS user interface, learn how elite cycling enforces the rules with our precision measurement technologies, analyze the newest member company in the metrology family, join an arm and a tracker in the same coordinate system. All that and a whole lot more. Let's join our correspondent, Bridget Benedetti, at the Zone.
Thanks, Bill. Hey, we're with Amir Grinboyne. Hi, Amir. Hey, can you tell us about your machine here?
Sure. This is the WLS400M by Hexagon Metrology. The WLS400M system is a portable, non-contact measurement system utilizing aerospace and automotive industry. It's primarily used for reverse engineering and part inspection.
Now this is called a white light machine, WLS400, but I swear that light was blue. Can you tell me a little bit about that?
Sure. The white light is basically a general terminology when this kind of technology was first introduced. Today, Hexagon utilized blue light as a power source, but the blue light spectrum is within the white light, so that's why we kept the terminology.
I see. Now, what kind of applications does the WLS handle?
The WLS400 can be found in a wide range of applications. In automotive industry, it's used for tool and die shop, stamped part measurement, sub-assemblies and assemblies, and up until production. In aerospace, you can find the system in incoming part inspection, closures optimization, step and mismatch, fastener measurements, and more. Over the past 15 years, process-driven algorithms were developed in order to support these applications.
Tell me a little bit more about the WLS400 platform.
Well, the platform was designed for this system. It provides the reachability needed in order to measure the parts in the shop floor environment. Furthermore, all the components are mounted on the pedestal, which makes it a one-person operation.
Now, you had mentioned earlier that this was used on the shop floor. How is this designed to have an ability to work on the shop floor?
The WLS400 utilized patent stereo vision technology, which allows the system to grab the image within an average of 10 milliseconds. This is part of the technology that allows us to work in the shop floor condition. On top of that, the optical head is carbon-based, plus the lenses are fixed, which basically enable the system to maintain the rough conditions.
I see. Now, why are there 3 cameras there?
The 3-camera setting provides an additional image for triangulation, resulting high certainty in the data that we collect. On top of that, it provides flexibility in viewing the measured object by 2 cameras, which in areas that may be reflective or not reachable in the right way, it's possible to measure.
Now, what kind of technology does the WLS400 use to do the measurements?
Unlike other systems who used scanning or point cloud on the material thickness in order to measure the feature, the algorithm of the WLS400 use 2D image analysis, allow extracting the feature dimensions out of that. This enables us to measure the features in a fast, as the process goes, without having to wait for the system.
I see. Now, can the WLS400 be easily automated?
Yes, this is a modular system. You can basically take the optical head, controller, and desktop and mount them into a robot. On the other hand, you can easily take the optical head off the robot by using an easy release.
Now, what are your qualifications and how much training is required to operate the WLS400? It seems very complicated.
Well, the WLS400 utilizes software functionalities which basically make the operator life easy. functions like full offline programming or visualization of the optical head and the directions where you need to approach to the part are already embedded in the software. So regardless to the operator experience, the software will guide you on how to measure and complete your measurement.
Wow. Now, we all have made major purchases, and when you buy something, you think about the price, but what's really the cost of ownership for a machine like this?
Well, when the system was designed, it was designed in repeatability and reduced cost of ownership in mind. For example, consumable parts are pretty much not exist. State-of-the-art cables, aerospace cables are being used for the system. 15 years of software algorithm, which makes the system highly reliable under shop floor conditions.
Wow, very impressive. Thanks, Amir.
Thank you very much.
Hi, now we're here with Sean Thielen. Hi, Sean. Hey, this is the 454SF. Can you tell me a little bit about this machine?
Sure. So the 454SF is a machine that's been built for the shop floor environment.
Oh, now what makes the machine so well suited for the shop floor environment?
Well, when we designed this machine, we took into account the environment of a shop floor situation where you're going to have airborne contaminants, you're going to have vibrations, thermal variations, and you need to also rearrange the shop floor on occasion. So we took all those things into account when we designed this machine.
So the shop floor contaminants, those were considered in part of the design process?
Absolutely. So a couple of the things that we did when we designed this machine is we said, well, this machine's going to be on a shop floor, so we need to build it with protection for the shop floor contaminants. So we added the bellows covers, we have hard bearings for the machine, and then we also mounted the scales upside down so that if any of the shop contaminants got into the bellows, they're not going to affect the machine.
I see. Now, the temperature on the shop floor, that can vary widely. Can you tell me how the shop floor, the SF, can adapt for those variations in the temperature?
Absolutely. So this machine was specially designed to handle those thermal variations, and it can handle the variations from anywhere from 15 degrees to 40 degrees C. And so through the special compensations that we've built for the machine, it can work just fine in any of those situations.
Now, earlier you mentioned deployment flexibility. Can you tell us more about what that means?
Sure. So shop floor, you're going to have reconfiguration taking place constantly. So you might have a line change here or there. You need to move this machine. So we've built the machine with casters already built onto it, and it's also designed at the width of a standard doorway. So if you need to reconfigure your shop floor and move the machine to a different position, you can do so very easily.
I see. Thank you. That's the 454SF from Hexagon Metrology. Hi, I'm here with Emily O'Day. Hi, Emily.
Hi, Bridget.
Hey, I see you have Leica Geosystems trackers on display. Why are they not part of the Leica track here at Hexagon Live?
Well, they are actually Leica Geosystem product. However, they are actually distributed and advertised throughout Hexagon Metrology channel. There's a big difference between the two industries. In this case, we are dealing with measuring in metrology. We're dealing with measuring from millimeters up until meters and accuracies in the microns levels, where in geosystems we're more between millimeters to meters to kilometers and looking at accuracies in the millimeters range.
I see. So what products do you have showcased here tonight?
So here we have the AT402 and the AT901. So with the AT402, the concept behind it was to create a tracker that was small, so you can see here it's small, and also, how to say, easy to use. So you can see here all these components actually fit in one case that we can carry on an airplane, for example, so transportation is not an issue.
Now, has this enhanced level of portability changed the way that your trackers are used?
Why, certainly. It has really. Not only is it portable, it is also battery operated and wireless communication. So this has really changed how they're used in the sense it's also IP54, and all these characteristics make it an instrument that can be used in our traditional industries, which are automotive and aerospace, but it's opening so many more new markets for us.
You mentioned IP54. What is that exactly?
IP54 is an IEC standard, and what that means is it guarantees a certain level of protection against dust and water. In this case, it is now possible, for example, to bring this tracker out into the desert and measure without worrying about sand getting in the encoders or inside in the instrument itself.
That's fascinating. What could the AT901 do that you haven't already mentioned about the 402?
Well, I mentioned that the 402 is a 3D tracker, so it gathers data based on X, Y, Z. However, with this one, it's a 6D tracker. So with this, we actually have T products. Here we have, for example, the T-probe. So instead of just an XYZ, we have an IJK, or an orientation based on this. It really truly makes the tracker a portable CMM. We can take this out on the shop floor rather than moving the part in to be measured.
Can it scan a part as well?
Not this is single probing, but we do have the T-scan. This is our laser line scanner. So this will digitize a part for reverse engineering or inspection purposes.
But doesn't that still require the user to move around the part to scan it?
Yes, it is a manual operation, but let's not forget that we have automated solutions. So we can use a TMAC or an AIC and to replace the actual human operator and have an industrial robot do the work for us.
Wow, that's fascinating. Now, earlier you mentioned that the AT402 was the easiest scanner for a user to use. Can you tell me a little bit more about that?
The AT402, embedded inside in this AT402, we have what's called power lock. This is how the beam acquires a target. Before we had to move our hand, try to find where the laser beam was. Now the laser beam finds the target on its own. The sensor does the work. In addition, we have measurement modes. The operator no longer needs to worry about what settings to set for distance and time-based measurements. It's all incorporated in the sensor itself.
Oh, that's great, Emily. Thank you. And we'll be right back after this break. We're back in the zone with Scott Sandwith. Hey Scott, I see you have a new product here for Hexagon called Spatial Analyzer, or SA. Can you tell me a little bit about that?
Absolutely. Spatial Analyzer is a product developed by New River Kinematics, which is a brand new company that was just merged into the Hexagon family, Hexagon Metrology family in January of this year. Spatial Analyzer is a software platform that integrates a number of different metrology systems together, and it helps our users take advantage of those in the most optimum way. And in the end, they're able to deliver the solutions and integrate metrology into their processes much more simply and much more confidently.
I see. So you have a CAD model here loaded with GD&T. Can you tell me how it will use that?
Absolutely. This wing spar is a good example where we're using GD&T to help automate metrology processes. It dramatically simplifies it from the user's perspective. What they're able to do is import the CAD data directly with the GD&T, harvest that information, create the feature checks, and then those feature checks are then automatically filled as the data is collected from the instruments, and as a result, when they finish their measurements, the reports are ready to be delivered.
I see. So does SA require a CAD model to measure a part?
Actually, that's a great question. And in most cases, we actually don't have CAD models in practice, and we have a broad user base that goes out and uses the devices in the most optimum way they can, and delivers the results without a CAD model.
Now I understand SA is used in a lot of automation projects. Can you tell me a little bit about that? Help me understand it.
Can do. What we've got with Spatial Analyzer is a great architecture that enables us to automate processes as opposed to automating it to a specific part. Most of our customers have a lot of different parts they have to produce. And one of the things and each one of them is unique. One of the things they do have in common, though, is the actual inspection process and the build process are all consistent. And as a result, What SA is able to do is automate those processes and not worry about the details and the uniqueness. The scripting process is able to wrap that and make it relatively easy for them to take the different parts and to drive a consistent process. And as a result, our customers are able to improve their productivity because they get a consistent and clean process.
Wow, that's really great. Thanks, Scott.
Thank you.
I'm here with Ken Woodbine. Ken, I noticed you have several software products displayed in this area. Can you tell me about that?
Well, I sure will. It's just a fantastic conference. We've got so much software here that the synergies are really palpable. And what we're doing is looking for ways that we can connect two or more products together to solve a new problem for a customer.
So you mentioned earlier new products. Are you presenting one of these new
Well,
products?
in fact, we are, several, one of which is a virtual measurement solution, which we're showing over here. And this, the advantages here are all about speed and accessibility, portability.
That sounds really interesting. How does it work in practical
Okay,
terms,
well,
though?
what we're doing is we're using our Windows software, which is designed to measure powertrain in very complex geometries. And we're using our Reshaper solution, which manages point clouds and has advanced meshing tools. Together, we can virtually measure a part in a fraction of the time it takes in traditional methods.
What are the other advantages of virtually measuring a part versus physically measuring it?
Well, besides the speed, if you think about the fact that there are a lot of parts that you may want to go out into the field and measure, large gears that require complex geometry measurement, but which are hard to get to a CMM. So a windmill gear, for example, maybe an excavator with gearing on it. Those would be ideal candidates for this solution.
That's really interesting, and it sounds really valuable for measuring. Thanks, Ken.
My pleasure.
Hi, we're here with Milan Kosick. Hey, Milan. I see you have PC-DMIS Touch on both CMMs and portable arms. Can you tell me a little bit about that?
Sure. Right here we have PC-DMIS Touch on our roamer arm, which is, as of July, will be our first release product in the Touch product line. And over there we have running on a CMM. So I can just quickly run through Touch here on this machine, tell a couple-minute demo. What you have here is a nice touch interface that we can scroll back and forth. We can pick a program, and we'll open up a program that we can basically see, scroll through it, look at detailed features, and run through various different functions in PC-DMIS Touch. They're all constructed in the same manner so that for a user, it's very simple to figure out how to actually utilize the software. The same principle that applies to the arm applies actually on the CMM.
Now, are these products available today?
We're just announcing PC-DMIS Touch Portable, but it will be available in July of this year, and the CMM product will be available sometime in October.
Can you give me even a little bit more detail about PC-DMIS Touch?
Sure. To go through a quick routine here, if I look at the program that we have here, let me go back to the home screen. If I come back here, that's actually just a photo, not the right thing. If I come back into the program itself, we have several features listed here. And if I go through a quick construction here, I can look at the methodology, ask to actually construct a feature, and intelligently features are listed here and filtered. So I can click to next, click on here and next, and click on done, and it constructs an actual point, and that point is a result of a circle 1 and a circle 2. So it's a very simple, very intuitive, very little training, and that's the intent of the actual product.
But what specifically does that mean?
What it means that it's meant to guide customers how to actually utilize the software. So without too much training, they can basically intuitively figure out what the next operation of the software actually is.
Now that sounds like just about anybody can learn to use PC-DMIS Touch. Is that true?
That is correct. Anybody in this room can actually do it.
Thanks, Milan. We'll be right back after this break. And we're back in the zone with Eric Hollenbeck. Eric, I see you're scanning this part with this machine, but earlier they were scanning it with the laser tracker. Can you tell me about that?
Yes, Bridget. This is the Romer Absolute Integrated Scanning Arm. It has rotary encoders in each of its axes, which report to the computer the exact location of the scanning head. So the scanning, just like the scanning head for the Leica laser tracker, the Leica laser tracker uses rotary encoders in its top rotation, rotary encoders in this location, and an absolute distance meter to know exactly where in 3D space it is. This uses the encoders of the arm, and the data from the laser pairs them together, sends it to the computer, then goes to the software to create a cloud of points.
This scanner looks similar to the scanner on the tracker over there. Can you tell me a little bit more about that?
Yeah, the trackers and the arms are fundamentally very different, and they solve a lot of our problems in one case and then also in the other case. When it comes to the arm, I can scan this part on this side and come around and scan on this side. That's one of the advantages of the arm. When it comes to the trackers, they don't do anything that they can't see line of sight. So if the laser from the tracker can't see where the scanning head is, if it's on the other side of the part, such as this, then it can't actually collect data. So one of the disadvantages of the arms is that I can only scan what I can reach. So I can only go to here or all the way on the other side, where the tracker could do the entire front of this part and for another 100 meters apart without having to do any moves.
I see. Now, what kind of applications and customers are using this technology currently?
This is our primary market is automotive. Our customers are GM, Ford, Honda, also BMW, Caterpillar are some of our bigger customers. But aerospace is a very close second. This is Boeing, Northrop Grumman, Lockheed, Airbus, of course, and also Spirit and SpaceX. They primarily are using it, especially in this sheet metal and the die forms, so that we can minimize drag on the airplanes and on the cars. This results in increased fuel economy, and also in the case of military, speed and stealth.
Now, I noticed that you have a ball probe attached to that scanner head. What's that used for?
Yeah, the ball probe enables you to do features quickly. I can measure this circle with just 3 or 4 points, and a plane with just 3 or 4 points with the contact probe, where if I scan it, then I'm getting a big cloud of points. I have to go subsequently back and tell the software what that feature is, that it's a plane or a circle, where the contact probe shows that it's automatically a circle.
Wow, really interesting. Thank you, Eric.
Thank you, Bridget.
And we're here with Tony Viana. Hey, Tony. This device looks like the same one that was with the laser trackers. Do I have that right?
Yes, you do. This is the Roma Absolute arm with the integrated laser scanner.
Now, you look like you're measuring a bike here. That's kind of interesting. Tell me a little bit more about that.
Elite bike racing today has it now has rules to govern the design, the shape and the dimensions of the bike frame. A bit like Formula One car racing or NASCAR or something like that. So it used to be that you could just measure a bike in the days when it was just made with some tubes, and you could do that just with a tape measure and a protractor. If you look at this bike here, you can actually see that the shape is much more complex. It's got a lot more swoop to it, I would say. So what happened is we were contacted by the World Cycling Federation, the UCI, and they asked us to develop a system that would be fast and accurate and above all portable, to allow us to check these bikes for dimensional problems and to check really that they're conforming to the rules.
So every bike in every bike competition has to be measured with the scanning arm? That sounds like it's going to take a lot of time.
Well, it's not exactly like that. If you look on that bike frame over there, for example, you'll see a seal from the International Cycling Union. And what that seal means is it means that that bike has already been certified using the Roma Absolute arm. So what that means is a racing team can go racing with that absolutely serene in the knowledge that the bike meets all of the rules governing the design of the bike frame.
So meeting the rules means no cheating. Now there was some talk about cheating with the Tour de France, right?
Yes, there was. That's been in the newspapers quite recently. And in actual fact, we were contacted by the UCI again last year to actually accompany them on some of the stages and check some of the bikes as they were coming in on the finish line. And we were able to sort of bring some results and show the UCI things that they hadn't seen before, and there was evidence of teams trying to gain an advantage.
So why do they use an arm? Why not use some other technology from Hexagon Metrology?
Well, like I was saying, really there are a number of factors, but I would say the key one is probably portability. If you think about the Tour de France, you know, that brings with it a whole bunch of logistical difficulties. So you can imagine there aren't many measurement systems around that would allow you to go into the middle of a field in rural France and check, you know, a complex shape to a very high accuracy.
Right, I understand. Now, does that mean that this system could be used for other sports as well?
Yes, that's exactly right. So it could be used for any sport that uses complex equipment, or rather equipment that has a complex shape.
So is this system similar to the roamer arm used in industry?
Yes, yeah, it's actually exactly the same. The only thing that we've changed in this case is the software side of the solution. So the hardware side of it is off the peg. What we've done is we've really isolated the most important commands that would allow you to check a bike from start to finish, and to do that as fast as possible. With the software in its standard configuration, I think to check a bike was taking around 50 minutes. With this kind of reduced interface that you can see here, we can do exactly the same thing in less than 10 minutes.
That's great. That's really interesting. Thanks, Tony.
My pleasure.
Back to you, Bill.
Thank you, Bridget. Well, that's all we have time for. Thanks for joining us here on this tour of the zone on HxGN Live TV.